Hi guys, I'm back, but as usual before I start, this is microphone number 3 for the upcoming contest. Okay, so sorry I was gone for the past couple of days, but I was backpacking, so it might be like this for the rest of the summer. I've really booked summer. But now on to science. So today I'm going to be explaining the Hertz, or Hz, as it's commonly denoted. So what are Hertz? They're a measure of frequency, example, times per second. So, first, the history of the Hertz. So, it is named after Heinrich Hertz, as you can see. You can check out him, but he's widely known for his studies of electromagnetism. And the Hertz was, right before the Hertz, there was cycles per second. As you can see, as it says up here, they're defined as cycles per second. It's the same thing, essentially, sir. Hertz and cycles per second. Almost the same thing. But anyway, cycles per second was used but for a while, but Hertz was replaced it largely in the 1970s, was when people started using Hertz. And if you need to say frequency, you still use Hertz to this day. Hasn't changed much, or at all. So, one total cycle. Anyway, so it's the complete waveform from where it starts, as in, like, right here. Follow the waveform to the same point as where it starts. So that right there, like right there, you could choose just at the beginning. It was 1 Hertz. But anyway, this is what I'm talking about. Total waveform is from, oh, that's kind of strange. Huh. I gotta try that, actually. But anyway, so it's the total waveform per second. The number of those total waveforms per second. Oopsies. Okay. That was not good. Okay. Now that we're back here, so to find out how many hertz, say, an audio wave is, you find out how many complete cycles per second. Say this was a constant sine wave of whatever hertz, we don't know. You find out, say you were looking at it on your computer. You had a little wave diagram like this one, and you were just generating a constant signal from your computer's sound card, and you just wanted to know how many hertz it was. You would look at that waveform, and to find out how many hertz it was, you would look at how many complete cycles were there per second. Okay, so you count up how many there were per second, or you can count out how many there were in 1 millisecond, and then multiply it by 1,000 to get it in a second, for 1 second, essentially. So you count the number of complete cycles per second, or if there's too many to count in 1 second, you count the number in 1 millisecond, and you multiply it by 1,000, and then that is your hertz. So that means that your complete waveform would have done whatever number of complete cycles per second, or whatever number of hertz. So here's an example. Okay, so we're in Microsoft Paint. Hopefully this will work out okay. But anyway, say we have here, this graph isn't even, but here we have your x-axis, and here we have your y-axis. Your x-axis is representing time, the big line is representing 1 second, and these are each a tenth of a second. So it'll be a 10th, 20th, 30th, 40th, 50th, 60th, 70th, 80th, and 90th, and a 100th of a second right there. So that's 1 second from there to there. On the y-axis, we have whatever, be it, I guess we can make it voltage here in this case, because I do like electronics. So one complete waveform, if we draw one here, we can count 1, 2, we'll make it a square wave, say. 1, 2, okay, so I got this done. Sorry, Paint's not really a great program to use for this sort of thing, but it has to suffice because I have no better software to do this. And I actually have no way of drawing this. I'm just drawing this with my mouse and keyboard. If I was using my mouth, I would have issues. Well, yeah. But anyway, this is a square wave here, as we can see. It has a 50% duty cycle. As you can see, we have 1/10 of a second, 2/10 of a second, 3/10 of a second, 4/10, half a second. And then from here, we have 1, 2, 3, 4, 5. So as you can see, we have another half a second, so that means 50% duty cycle. So I probably right here, it would have gone up also, transitioning. Anyway, as you can see, from this point here, I guess we can denote this with a green little slash. From that point there to that point there, that is one complete waveform, as in it's been down for half a second, it's gone up, it's been up for half a second, and then back down. So as you can see, this is the same point on our waveform, because if I draw our little waveform here a bit more completely, sorry, I'm just doing this really fast, so it's not going to look very pretty. But anyway, you can see that from the one complete cycles from where it starts to the same point on where it starts. So, and then this would have been like at the top of that and whatever, and so with that. And anyway, these ends are just going to go on forever right there. Anyway, so as you can see, is again denoted by our green. Say we pick the starting point to be after the down transition. That's the down transition right there, so that's our starting point, okay? So we're going to wait till right after the down transition again. So we have down, up, up, down, right after the down transition. That's one complete waveform. Then we do it again, that's another complete waveform. So that's how I know this is one complete waveform. So right here, our main example, forget about that example here. Oops. Okay. Forget about this example here. I'll just cross that out. Ooh. Okay. So that's how I know that this is one complete cycle for a square wave. Also, we could do it with a sine wave, but it wouldn't look very pretty. Or I could try. I can actually pause hypercam too. Anyways, so that means this is done one complete cycle per second. That means it's doing 1 Hertz right now, okay? Now this new waveform I'm going to draw, it's going to be blue. It's going to do 2 Hertz, as in 2 complete cycles per second. Okay, so if this is our second mark, I think I better draw our 1 second mark a bit. It's getting kind of complicated here. But anyway, so forget about this red diagram here, and just focus on the blue overlay, okay? So you're going to say, how is this 2 cycles per second? Because if our cycle is at the bottom of our downbeat, but it is. Look, if you check, this right here can be the beginning of our cycle. So right when it gets to this point, right? Just after the down whatever, right? That's 1. From there, we go up. Does the same exact thing again there. That makes it 2 cycles per second. 2 complete cycles of this wave have gone past in 1 second, meaning that this wave is doing 2 Hertz. Now I'm going to draw another wave. This wave is going to do 10 Hertz. 1 sec. It'll be yellow. Okay, so it's drawn. And just so you can note, the frequency, which is Hertz is a measure of frequency, does not depend on the amplitude. So right here we have different amplitude waves. The amplitude of these waves doesn't matter. Also note that this graph I've drawn here is not the scale, so that's why some of these crests might look a bit larger. So let's count out how many Hertz this waveform is, okay? We'll get our green little marker here. That's our beginning, so we trace out the waveform. That's 1 time per second, 2 times per second, 3 times per second, 4 times per second, 5 times per second. Okay, so I lied. Sorry. Oh well. Anyway, this wave right here, the yellow one, is doing 5 Hertz. I lied before. It was actually, I was not thinking when I drew this example. Sorry. Anyway, so you can see it's done the complete waveform 5 times in 1 second. So that means it's doing 5 Hertz. So now if you, and also just to give another example, we'll do the same wave, draw the same waveform with a triangle wave, the same as the yellow, with a triangle wave and with a sine wave, just so you can see what a complete one looks like on that. Because you will encounter other types of waves besides just square waves. I just did them for simplicity. So here it is. Here is the little sine wave. I haven't bothered to draw it out here because it takes forever to draw one of these things, but it actually looks nice. But as you can see, we'll get out our green little slash here, and we'll see that this one is also doing 5, should be doing about 5 Hertz, but let's count it out. So this will be the beginning of our waveform here, starting exactly on the x-axis, about to go up. So we do that. That's 1, 2, 3, 4, 5, yeah, because you can see if I was to draw that waveform out further, I just will draw it out one more half cycle. Oops. If I was to draw it out one more half cycle, you could see how I'd actually draw these things. Okay, if I was to draw out one more cycle, you see this is about where it's about to go up. So that is doing 5 Hertz. So this is what one complete cycle, I'll trace over one complete cycle of this sine wave with the purple tracer. I probably won't do it very good, but as you can see, exactly back to where it started. So that is one complete cycle of sound wave. So just remember, Hertz is number of complete cycles per second. And I hope my little example here is just help you to understand how Hertz actually works and how you can measure them. And keep in mind that, say, this black line, which keeps getting written over by all my other written drawings. Sorry if this drawing is getting a bit too cluttered for you. It is getting too cluttered for me also. Okay, there we go. Say that second mark and these little 1/10 of a second marks were actually not that. Say this was a 10 milliseconds and each of these was a millisecond mark, okay? That means this wave would have completed one cycle in 2 milliseconds. That means it would complete 500 cycles, complete cycles per second, or be a 500 Hertz waveform, because 1 millisecond is 1,000th of a second, and that means 1,000 divided by 2 is 500 because of 2 milliseconds. Because of this wave takes 2 milliseconds to complete one complete cycle, so that means it only does the wave 500 times per second. So, and then this could be with microseconds too, in which case then it would do it 5,000. And I think now we need to go over the SI prefixes that are commonly used with the Hertz, because you'll often see the term gigahertz, megahertz, kilohertz, and you really need to know what those mean. Okay, so I've cleared my little thing here, and I guess we'll just get a text box and we can type in it. So the term, you'll see this, Hertz, right? That's just a regular 1 Hertz, 1 cycle per second. The term kilohertz, I'm not sure that you can see this, but the term kilohertz means 1,000 Hertz. So if something is oscillating at 1,000 Hertz, it's the same thing as 1 kilohertz. Gosh, I can't pronounce anything today. So that means that if 1 kilohertz is equal to 1,000 Hertz, so 1 kilohertz is 1,000 complete cycles per second. Another thing, one step up, megahertz. Actually, it's megahertz. Not sure that you can see this too well, but anyways, MHC, megahertz, that's 1 million Hertz, okay? It's a step up from 1,000. So I've switched now to the Wikipedia page on SI prefixes, and as you can see here, go through 1 kilohertz is 1,000 Hertz, megahertz is 1,000,000 Hertz, gigahertz is 1,000,000,000 Hertz. We're using short scale here. Most people use short scale. And you're pretty much not going to see anything past gigahertz, which is 1,000,000,000 Hertz. So yeah, and you probably won't see anything down here, so I'm not going to review it. But anyway, that is Hertz. Thank you for watching. Just as an overview, at the very end, we're going to go overview Hertz. So essentially, a Hertz is a frequency, so how many times something happens per second, and it's how many times the complete cycle, the complete waveform, happens per second. So if one complete waveform happens per 1 second, that's 1 Hertz. It can be used with the common SI prefixes, such as kilo, mega, and giga. Kilo being 1,000, mega being 1,000,000, giga being 1,000,000,000. And essentially that is Hertz. So here is a little quiz. Not sure if this is going to be a thing that sticks, but if something is oscillating at, say a CPU is oscillating at 5.0 gigahertz, how many complete cycles of the waveform are there? That's 5 gigahertz, and in regular decimal form. Okay? Thank you for watching. I really appreciate it. Thank you for commenting, if you comment, but please comment. Please rate, subscribe, do whatever else you can to show support. Again, thank you so much for watching, and I thank in advance anybody who rates, subscribes, comments, or does anything to show their support. Thank you guys in advance. So, bye.